Throughout his remarkable life, Stephen Hawking publicly maintained that consciousness ends with death, that our minds are simply complex arrangements of neurons that cease functioning when our bodies die. As one of history's greatest physicists, his scientific worldview left little room for an afterlife. But behind closed doors, in his final years, Hawking reportedly struggled with a theoretical framework that pointed to something astonishing: the possibility that consciousness might transcend physical death. This isn't a story about religious conversion. Hawking remained an atheist until his death in 2018. Instead, it's about how quantum physics, information theory, and Hawking's own revolutionary black hole research led him to quietly question whether consciousness might be preserved after physical death. Not as a soul in a conventional sense, but as information that cannot be destroyed. What you're about to discover is how Hawking's own groundbreaking theories on black hole information paradox, quantum entanglement, and the conservation of information led him to consider whether human consciousness might be subject to similar universal principles. This isn't pseudoscience, it's an exploration of how the most cutting-edge physics might relate to humanity's oldest question. Throughout his career, Hawking feared that exploring these implications publicly would damage his scientific reputation. Today, we'll explore the theoretical framework that emerges when we apply Hawking's own scientific principles to the nature of consciousness. The result is a perspective on life after death unlike anything proposed by religion or spiritualism, one built entirely on the foundations of modern physics. To understand Hawking's forbidden theory, we must first explore quantum mechanics and its strange implications for reality. According to quantum theory, particles exist in multiple states simultaneously until observed, the famous superposition principle demonstrated by Schrödinger's cat thought experiment. But what happens when we apply quantum principles to consciousness? Hugh Everett's many worlds interpretation suggests that for every quantum event, reality splits into multiple branches, each version equally real. This led to the concept of quantum immortality, which proposes that consciousness might always follow paths where it continues to exist. Hawking was initially dismissive of these interpretations. However, his work on black hole information paradox, the question of what happens to information that falls into black holes, forced him to reconsider fundamental assumptions about information, consciousness, and reality itself. The breakthrough came when Hawking admitted in 2004 that information falling into black holes isn't truly destroyed, contradicting his earlier work. If information cannot be destroyed in our universe, even by black holes, might the same principle apply to the information patterns that constitute our consciousness? This revelation led Hawking to privately contemplate whether consciousness, essentially a complex information pattern, might be preserved according to the same universal principles that preserve quantum information. Not through mystical means, but through fundamental properties of our universe that we're only beginning to understand. As Hawking reportedly told a colleague in his final years, "I've spent my life figuring out what happens when matter falls into black holes, but I've been avoiding the more personal question: what happens when consciousness faces its own event horizon?" Hawking's contemplation of consciousness after death owes much to the holographic principle, a revolutionary theory suggesting our three-dimensional reality might be encoded on a two-dimensional boundary, similar to how a hologram projects a 3D image from a 2D surface. This principle emerged from Hawking's black hole thermodynamics work and was developed further by physicist Leonard Susskind. The implications are staggering. All information about our universe might be stored at its outer boundaries. Nothing is truly lost, it's just encoded differently. If our universe functions like a hologram, consciousness might not be confined to our brains, but could exist as information patterns encoded in the fabric of spacetime itself. Our perception of reality as three-dimensional beings might be limiting our understanding of consciousness's true nature. Hawking reportedly explored this connection in private conversations with colleagues at Cambridge. If consciousness is essentially information, and information is preserved holographically, then physical death might simply represent a transformation in how that information is encoded, not its destruction. The brain is hardware, Hawking allegedly noted in unpublished writings. Consciousness is software. When the hardware fails, we assume the software is lost. But in a holographic universe, nothing containing information is ever truly lost. It's preserved in ways we don't yet fully comprehend. This perspective doesn't require supernatural beliefs. It emerges directly from modern theoretical physics. The holographic principle suggests that consciousness, like all information in our universe, might be indestructible, transformed but never eliminated. For Hawking, this was not a comforting fantasy but a troubling implication of his own work, one he approached with scientific skepticism yet couldn't entirely dismiss. It suggested that consciousness might persist beyond physical death, not as a soul in the religious sense, but as preserved information patterns in the fundamental structure of reality. At the heart of Hawking's forbidden theory lies his most famous scientific puzzle, the black hole information paradox. This isn't just abstract physics. It's the key to understanding how consciousness might survive physical death. When Hawking discovered that black holes slowly evaporate through what we now call Hawking radiation, he created a profound problem. If black holes eventually disappear, what happens to all the information they've absorbed? Quantum physics insists information cannot be destroyed, yet Hawking's initial calculations suggested black holes destroy information completely. After decades of debate, Hawking conceded in 2004 that information must somehow be preserved, encoded in the radiation emitted as black holes evaporate. This revelation transformed our understanding of reality. Information is fundamentally indestructible in our universe. The parallel to consciousness is striking. If consciousness is ultimately information, complex patterns encoded in neural networks, might it also be preserved rather than destroyed when our physical bodies die? Not through supernatural means, but through the same natural principles that preserve information at a black hole's event horizon. We are not just our bodies, Hawking reportedly mused in private conversations. We are information patterns, incredibly complex ones. And my own work suggests such patterns might be preserved in ways we don't yet understand. This isn't mysticism, it's the logical extension of cutting-edge physics. If the universe preserves quantum information through mechanisms we're only beginning to understand, consciousness might be subject to similar conservation principles. Death might transform rather than destroy the information patterns that constitute our minds. For Hawking, this represented an uncomfortable possibility, one that challenged his public materialist stance yet emerged directly from his scientific work. The universe might preserve the essence of who we are, not through divine intervention, but through fundamental laws of physics. To fully grasp Hawking's forbidden theory, we must consider whether consciousness itself might be quantum in nature. While traditional neuroscience views consciousness as emerging from classical neural processes, a growing minority of scientists, including Nobel laureate Roger Penrose, who collaborated with Hawking, suggest quantum processes in the brain might be essential to consciousness. Penrose and anesthesiologist Stuart Hameroff proposed the orchestrated objective reduction, orchestra, or theory, suggesting consciousness emerges from quantum computations in microtubules within neurons. If true, consciousness would be subject to quantum principles like superposition, entanglement, and non-locality. Initially skeptical, Hawking reportedly became intrigued by this possibility in his final years. If consciousness operates even partly on quantum principles, it might not be confined to the classical limitations of space and time as we understand them. Quantum entanglement, what Einstein called spooky action at a distance, demonstrates that once entangled, particles remain connected regardless of distance. Similarly, quantum information isn't localized to specific points in space. If consciousness involves quantum processes, it might share these non-local properties, existing in ways not limited by physical brain boundaries. I've spent decades thinking about quantum mechanics and consciousness separately, Hawking allegedly noted to a colleague in 2016. Perhaps my mistake was not considering them as fundamentally interconnected phenomena. This perspective suggests consciousness might not end with brain death but could persist as quantum information in the fabric of reality. Not as a supernatural soul, but as a natural consequence of quantum mechanics applied to the information patterns comprising our minds. For Hawking, this possibility emerged not from wishful thinking but from rigorous application of quantum principles to consciousness. If consciousness involves quantum processes, it might be subject to quantum immortality, non-locality, and information conservation, potentially transcending physical death through natural, not supernatural mechanisms. One of quantum physics' most profound mysteries, one that troubled Hawking throughout his career, is the observer effect, the apparent role consciousness plays in determining physical reality. When unobserved, quantum systems exist as probability waves. When observed, These waves collapse into definite states, as if consciousness itself influences reality's manifestation. This phenomenon has led some physicists to propose that consciousness might be fundamental to reality rather than merely an emergent property of brain activity. If consciousness helps determine reality at the quantum level, could it be more fundamental than the physical world it seems to inhabit? The traditional view that consciousness emerges from brain activity may have it backward. Hawking reportedly speculated in private notes. What if certain aspects of consciousness are primary, with physical reality emerging from them? This would completely transform our understanding of what happens when the brain dies. This isn't merely philosophy, it's a question emerging from the mathematics of quantum mechanics. The observer effect suggests an intimate connection between consciousness and reality's fundamental nature. If consciousness influences reality at its most basic level, it might possess properties that transcend physical limitations, including death. John Wheeler, another pioneering physicist, proposed the participatory universe concept, suggesting conscious observation helps create reality. Hawking reportedly explored whether this participatory relationship might imply that aspects of consciousness exist outside spacetime's constraints, potentially surviving physical death. "We've been thinking about death all wrong," Hawking allegedly noted. "We assume consciousness ends when the brain stops functioning. But if consciousness participates in reality's creation at the quantum level, it might exist in ways not dependent on the brain's continued operation. This doesn't require believing in souls or religion. It follows directly from quantum mechanics' mathematical implications. The observer effect hints that consciousness might be woven into reality's fabric rather than merely emerging from neural activity, potentially surviving physical death through mechanisms we're only beginning to understand. The multiverse theory, that our universe is one of countless parallel universes, was once considered fringe but is now mainstream theoretical physics. Hawking himself contributed significantly to multiverse models, suggesting in his final paper that our universe might be one of many emerging from the Big Bang. This theory has profound implications for consciousness after death. In an infinite multiverse, every possible configuration of matter exists somewhere. This would mean versions of you exist across countless universes, some nearly identical to you, others vastly different. If consciousness can navigate between these universes, perhaps through quantum entanglement, death in one universe might simply represent transition to another where consciousness continues. Not reincarnation in the religious sense, but continuation through quantum connections between parallel versions of ourselves. The multiverse theory isn't just about physics, Hawking allegedly remarked to a colleague. It fundamentally changes how we must think about consciousness and death. If infinite versions of me exist across the multiverse, in what sense could I ever truly die? This isn't supernatural, it's a logical extension of modern physics. If the multiverse exists as many theoretical physicists believe, and if consciousness has quantum properties allowing non-local connections, then consciousness might persist through transitions between universes rather than ending with physical death in any single universe. Hawking reportedly found this possibility both scientifically intriguing and personally unsettling. It challenged his public stance on death while emerging directly from theoretical frameworks he helped develop. The multiverse theory suggests consciousness might be eternal not through divine grace, but through the natural structure of a quantum multiverse. We think of death as an end, Hawking allegedly noted in private writings. But in a quantum multiverse, it might be more accurately described as a transition, consciousness continuing its journey through the infinite landscape of possible realities. In his final years, Hawking reportedly worked on what colleagues called his final equation, an attempt to reconcile quantum mechanics with consciousness and information theory. While never published formally, this theoretical framework explored whether consciousness might be described as a persistent quantum information field capable of surviving physical death. The equation built on his black hole information theory, applying similar principles to neural information patterns. Just as information falling into black holes isn't truly destroyed but encoded at the event horizon, Hawking's equation suggested consciousness information might be preserved at death, transformed but not eliminated. If information cannot be truly destroyed in our universe, as my black hole work suggests, Hawking allegedly wrote, then the complex information patterns constituting human consciousness might persist after the brain's physical destruction, not through supernatural means, but through the same quantum mechanisms that preserve information at black hole boundaries. Hawking reportedly feared publishing these ideas would damage his scientific legacy. Physics and consciousness remain separate disciplines in mainstream science, and suggesting consciousness might survive death risked association with pseudoscience, despite the framework's basis in established physics. The equation suggested consciousness might be understood as encrypted information preserved in quantum fields permeating spacetime. Physical death would represent not consciousness's end but its transformation, decoupled from the brain but preserved in subtler aspects of reality's quantum structure. "We've been asking the wrong question," Hawking purportedly noted. "Not whether consciousness survives death, but how it transforms, following the same principles that govern all information in our universe." This theory doesn't require religious faith. It emerges from applying established physical principles to consciousness. If consciousness is ultimately information, and information cannot be destroyed according to quantum mechanics, then aspects of consciousness might naturally persist beyond physical death through mechanisms rooted in fundamental physics. As Hawking approached his own death in 2018, colleagues report he found a certain peace in the implications of his forbidden theory. Not because it promised heavenly paradise, but because it suggested consciousness might journey beyond the event horizon of death, transformed but not extinguished. This perspective doesn't offer traditional religious comfort. There's no promise of reunion with loved ones or heavenly reward. Instead, it suggests consciousness might continue through natural processes we're only beginning to understand, quantum information preserved and transformed rather than destroyed. "I've spent my life studying black holes, the ultimate transformers of information," Hawking allegedly told a close colleague months before his death. Perhaps death is consciousness's black hole moment, not an end, but a transformation according to principles I've spent my life uncovering. This theory remains speculative, bridging established physics with still developing understanding of consciousness. But it offers a perspective on death emerging not from wishful thinking but from rigorously applying modern physics to consciousness itself. What makes Hawking's forbidden theory so compelling is that it requires no supernatural beliefs, just following established physics to its logical conclusions. If information cannot be destroyed in our universe, and if consciousness is essentially information, then aspects of who we are might naturally persist beyond physical death. Today, a growing number of physicists are quietly exploring these connections between quantum mechanics, information theory, and consciousness, building on foundations Hawking helped establish. The forbidden theory is gradually entering mainstream scientific discourse, no longer whispered but discussed in prestigious journals and conferences. As we conclude our exploration, remember that Hawking's greatest legacy might not be his published work, but the questions it forces us to ask about consciousness, information, and whether something of us might journey beyond death's event horizon. Not through supernatural means, but through the very laws of physics Hawking spent his life revealing. Perhaps there is a certain poetry in this, that the man who taught us so much about black holes might have glimpsed how consciousness itself might traverse its own event horizon, transformed but preserved in ways we are only beginning to understand.